In the previous session, I explained about the crystalline solids and the four types of crystalline solids. Today, we are entering into the next topic in the solid state. It is about crystal lattice and the unit cell. So, these two terms are related with the internal structure of the crystals. What is meant by internal structure? So I told you that all matter consists of tiny smallest particles called the atoms, molecules or ions. In the crystalline solid, I told you that these constituents are arranged in a regular way. So in what way, in what pattern these particles are arranged in crystalline solid refers to the internal structure. What is the purpose of knowing internal structure of a crystal? I hope you remember we use different crystalline solid for different purpose. See, this chalk is used for writing on the blackboard. Diamond used for different purpose. Ice cube for a different purpose. So likewise, we use different crystalline solid for a different purpose. So that usage is decided by the properties possessed by that particular crystalline solid. The properties are correlated with the structure. Depending on the structure, internal structure of the crystal only, the properties exist. Based on the properties only, we use the crystals for different purpose. So, the structure of crystals is very important in understanding the properties and usage of crystals. So now, moving to the crystal, I told you that these particles are arranged very regularly in the crystalline solid. How they are arranged? So that is dealt in the crystal lattice and unit cell. So before entering into these two terms, we have to be familiar with another term. One term is crystal lattice, second is unit cell, and third is coordination number. Coordination number. So I told you that crystalline solids are characterized by definite orientation. Here orientation means in what way the arrangement is there. So definite orientation, important characteristic of crystalline solids is that the atoms or molecules have definite orientation relative to one another in a three-dimensional pattern. That is, in a three-dimensional pattern, these particles are arranged in a particular manner. So that manner, the way in which they are arranged, is related to crystal lattice and unit cell. So I can define crystal lattice like this. So in a crystal, millions and millions of atoms or molecules are present. How they are arranged in the whole crystal is related with the crystal lattice. How they are arranged. So the arrangement is very regular. So I can define crystal lattice like this. A regular arrangement of all atoms or molecules throughout the crystal. So again I repeat, throughout the crystal in three dimension refers to crystal lattice. A crystal may contain millions and millions of atoms or molecules. All the particles you consider, how they are arranged, that refers to crystal lattice. So unit cell, so say this is one crystal and you have millions and millions and millions of atoms. So if you consider the whole crystal, all millions and millions of atoms and their arrangement, it is called crystal lattice. So the crystal lattice consists of a unit cell. What we mean by unit cell? If you consider a smallest portion, the smallest portion within the crystal lattice that speaks the structure of the whole crystal lattice. That is called the unit cell, the smallest portion. In the smallest portion, if you observe the arrangement of the atoms or molecules, the same thing is repeated throughout the crystal. So by knowing the smallest portion, we can understand the entire structure of the crystal. That smallest portion is called the unit cell. So I can define unit cell like this. Basic, repeating structural unit of a crystalline solid is called a unit cell. So crystal lattice refers to the whole crystal. Unit cell refers to the smallest portion of the crystal lattice. By understanding unit cell, we can very clearly understand the internal structure of the crystal that refers to crystal lattice. I can give an example. So see, I am teaching in a classroom and students are sitting in the classroom. How the students are sitting in an ordered manner. So assume in our school all of you are sitting in the bench. A bench can accommodate 4 students in our school. So say 48 students are there in a classroom. So in one bench, 4 students. I have 3 rows of benches. In each bench, 4 students are sitting. I have to accommodate 48 students means I can have 1, 2, 3, 4 bench in each row. So one bench, 4 students. 12 bench, 48 students are accommodated. So same arrangement is repeated in all the rows and all benches. If 96 students are there, it is double. It is still more 12 benches and 96 students are accommodated. But the same thing is repeated. If we consider the 48 or all the 96 students, this refers to the whole arrangement of the classroom. Likewise, if you consider all the atoms in a crystal under arrangement, it is called the crystal lattice. Say, I have 500 students gathering. I have to accommodate 500 students or 400 students can be accommodated. Remember our auditorium in the school. There we have about 120 benches to accommodate the students. Even if there are 400, 500 students, we can accommodate all the students, but in the same way. We can have 4 or 5 or 6 rows, and each row may have 20-25 benches. Even 500 students can be accommodated, but in the same way. This is repeated. So if you consider all the 500, it refers crystal lattice. If you consider only one bench, it is like unit cell. So if I want to know how the students are sitting in the auditorium, I need not look into all the benches and all the students. Just by looking one bench. 4 students are sitting in a bench. The same thing is repeated in all the bench, in all the row, the whole auditorium. So the arrangement in the bench is like unit cell. The arrangement in whole auditorium is crystal lattice. So this is crystal lattice and the unit cell.